Hello, this is video tutorial on depth first search. Last time we saw about breadth first search in graph, but today we are going to see depth first search implementation of the graph. Okay, here is this is the graph for which we are going to find the depth first search, and this is the adjacency list representation of the graph, the one at the left side. Okay, this is the adjacency list representation of the graph, whereas this is the real graph that we are going to consider here in this tutorial. So as to display the given graph in depth first search, there are certain things that we have to consider. We have to use Boolean type array of the size equal to the node, Boolean type array of the size equal to the number of nodes, and we use the stack. Last time I told you about breadth first search. In breadth first search, what we used last time is queue data structure. We used queue data structure for breadth first search, whereas in depth first search, the typical data structure that we are going to use is stack. There is another variable s that we are going to use, and then the display task. So 1, 2, 3, 4. There are 4 tasks that the function that we are going to consider will do. They are these 4 tasks that the function we are going to consider is going to do. Anyway, let's see the code, the highlight of the code. Okay, I told you about the graph code last time. The implementation is the same with the breadth first search source code and the depth first search source code is the same except this function. So the rest of the code is the same except this function. This function is different from the implementation of the breadth first search. So this function, which is depth first search function, is different from the source code of breadth first search. The rest of the code is the same. The rest, everything is the same except this function. So we have to just emphasize our time more on this function rather than the rest. So what does this function do? First of all, as I've told you, there is Boolean type array of the size equal to the size of the nodes. We create the Boolean type array, which is this, and then we set everything false to mean that no node is visited for the first time. And then we create the stack. We create this, we set everything 0, which is to mean that unvisited. Then we create this stack, and for the first time we put the initial node from which we are going to display in depth first search inside the stack. From which node are we going to start to display in depth first search? That node should have to be put inside of the stack for the first time. So that's why we create the stack and then put that number inside the stack. The rest of the task is accomplished using this while loop. So this while loop does everything remaining once we get the first element inside the stack. So first of all, what we do is we take the top element inside the stack onto the S. We take the top element in the stack into the S for the first time. Initially there is nothing. Inside this also we have nothing. Then once we declare this Boolean type array and then set everything 0, then we take the initial node from which we are going to display in depth first search inside the stack, and then the element inside the stack, which is at the top, is put inside the S, on S variable for the first time. inside the while loop. So once we put the initial element inside the stack, then we have the while loop does this. It takes the top element, which is currently 0 on S, and then it cancels or it pops that element from the queue, from the stack. So it pops it from the stack once it has put inside the queue. Then the next step is, if that number which is on S, if it's not visited, just make it visited and then display it. Make it visited and then display it. Okay, I hope. Okay, anyway, no matter which sequence we use, but let me do this one. Okay, if that element on S is not visited, first display it, say out, first display it, and then make it visited, which is, I make it visited. Visited means that's 1. 0 means unvisited, 1 means visited, 1 means true, 0 means false. Okay, if we have made this, the next step is using this iterator variable. We have to find what is currently, that is 0. Using this iterator variable, we have to do this. I equals to adjacent of 0 begin. I is different from adjacent of 0 int I plus plus. Each time this is checked. What's our S value currently? That is 0. Adjacent of 0 begin until adjacent of 0 int. We have to search every adjacent of 0. So adjacent of 0 begin is which one? Adjacent of 0, 0, this one. Adjacent of 0 begin means the beginning adjacent of 0. I is at this location. If this element is the element found at I's location, is it visited or not? Is it visited? If that number is not visited, we put inside the stack. If it is visited, we search the second adjacent of 0. So if this number visited, adjacent of 0 begin, is it visited? It's not visited. If it is not visited, if it's not visited, we have to put inside the stack for the first time. So that's 1 is not visited. Then I increments again to the second adjacent. It increments here. If the element found at I's index, is it visited? I is a pointer where star I is the element found at that location. Star I is the element found at that location. If that number currently I's location is exactly where 2 is found, if the number within the I, is it visited or not? Is 2 visited? Is 2 visited here? It's not visited. So if it is not visited, we have to put inside the stack. That is, we have to put inside the stack. And then I increments to where? This. I execute this as far as I is different from adjacent of 0 int. Adjacent of 0 int means at the end of this, outside this adjacent. Once I is outside this adjacent, this is false. This condition is false, therefore inside is not executed. Therefore the next step is, we have done this. We have found adjacent of 0 and we have put inside. First of all, 0 is put inside, and then inside the while loop 0 is assigned to S. Because of that S number is not visited, we displayed, and then we made it visited. Next, inside the for loop, we iterated all adjacent of 0, and after finding adjacent of 0 which are unvisited, we have put them inside the stack. The next step is once we have completed this, the while loop again checks whether the stack is empty. It's not empty. Take the top element on S. Take the top element on S, which is 2. Put it in on S, and then immediately pop from the stack, because once we put on S, immediately we have to pop. Then if this number is the number on S, is it visited or not? If it is not visited, we have to display and make it visited. Is it visited or not? Is number 2 visited? We have to check it here. It's not visited. So first display, and then make it visited. Okay, once we have made this, the next step is we have to find adjacent of 0 using for loop. What does for loop do? For loop finds every adjacent of 0, adjacent of 2 within the list. So what are adjacent of 2? What are adjacent of 2? Adjacent of 2 are 0, 3, and 4. That means adjacent of 2 is 0, 3, and 4. Among these 3 numbers which are unvisited, 0, 3, 4. 0, 3, 4. 3 and 4 are unvisited. If it's unvisited, if that number is not visited, we have to put inside the stack. So 3, that is 3 and 4. Okay, we have put inside the stack. The next step is we have to go to the while loop. We have to go to, once we put inside, go to the while loop, and then what you do is take the top element on S, because the stack is not empty. Take the top element, which is 4 on S, and then immediately pop that element from the queue, as the code says. What's next? The next step is okay, the next step is if this number visited or not. Is it visited? It is not visited. Immediately display it, and then make it visited. Because if the number is not visited, because we display and we make it visited. The next step is we have to find adjacent of 4 which are unvisited. Inside the for loop, we find adjacent of 4 which are unvisited. So what are adjacent of 4? That is 2, 5, 6. Adjacent of 4, 2, 5, 6. Are they unvisited? 2, 5, 6. 2, 5, 6. Are they unvisited? Only 5 and 6 are unvisited. So we put 5 and 6 only inside this. 5 and 6. Okay, we put inside. Then what's the next step? After for loop, we have to go to the while loop. Then what? The while loop checks whether this is empty. Then if it's not empty, take the top element on S, that is 6. And then immediately pop it. Okay, immediately pop it, and then is this number visited or not? Is 6 visited or not? If it's unvisited, we have to first display and then make it visited. So it's not okay. 6 is not visited. Yes, it is not visited. We have to immediately display and then make it visited. That is 6 is visited. Once we make this, we have to find adjacent of 6 which are unvisited. What are adjacent of 6? That's 4. But here is 4. Adjacent of 6 is what? 4. Is it visited? Is 4 visited? Yes, it's visited. So we have nothing to do. We cannot insert 4 inside the stack because it's already visited. Only unvisited elements should be put inside the stack. Next, after the for loop, what we do is we go back to the while loop. we take the top element on S, we take the top element on S, which is 5 currently, that is 5, and then immediately we have to pop, once we do this, we have to check whether this number is visited or not. Is number 5 visited? It's not visited here because it says it's unvisited. So if it's not visited, just immediately make it display it first and then make sure that it's visited. So I assign 1 because I have already visited. What's next? Once we do this, we have to find adjacent of 5, which is unvisited. What's adjacent of 5? First of all, adjacent of 5 is 3 and 4. Adjacent of 5 in this, that is 3 and 4. 3 and 4. So is 3 and 4 unvisited? 3 and 4. Only 3 is unvisited, so we have to put 3 inside the stack. 3 inside the stack. Again, after the after the for loop, we have to go back to the while loop and take the top element on S. So the stack is now empty, so take the top element on S, that is 3, and then immediately pop that element from the stack. Is this 3 unvisited? Is it unvisited? If it's unvisited, just do these 2 tasks. If it's unvisited, it's 3 visited, it's unvisited, that's 0. So we have to first display 3 and then make it visited. Then the next step is we have to go to the for loop. After doing this, we have to go to the for loop, and what are adjacent of 3 which are unvisited? What are adjacent of 3? Adjacent of 3 are 1, 2, 5. 3, 1, 2, 5. Are they unvisited? 1, 2, 5. Everything is visited except 1. So we have to put only 1 inside the stack. After the for loop, we have to go back to the while loop again and take the top element on S. Top element on S, because the stack is not empty. Just take top element on S and then pop that element from the stack. Immediately, is 1 visited or not? Is 1 visited or not? It's not visited, so we have to first display, as the code says. First display 1 and then make it visited. So we have to find adjacent of 1. After just displaying and make visited, we have to find adjacent of 1 which are unvisited with for loop. So what are adjacent of 1 which are unvisited? 0 and 3 are the adjacent, but here everything is visited. So we have nothing that is unvisited to be put inside the stack, because everything is visited. Everything within this condition is false. Adjacent of 1 unvisited, 0 and 3 are already visited. So we don't put anything inside the stack. So we go back to the while loop. We go back to the while loop and take the top element on it, because we don't have element, because the stack is not empty. So we take the top element, that is 3 on this, and then we immediately pop it. And then is this element visited? Is it unvisited? No, everything is visited. So inside this nothing is done, because 3 is already visited. So next what we do is we have to find adjacent of 3 which are unvisited. What are adjacent of 3? That is 1, 5, 1 to 5. 1, 2, 5. 1, 2, 5. So adjacent of 3 which are unvisited? No, there is no. So this for loop doesn't do anything for adjacent of 3 because everything is visited. So next we go back to the while loop, and while loop This is the stack empty. No, just take the top element, which is 1, and then immediately pop. And then the next step is 1 visited or not for this part. Is it visited or not? If it is unvisited, just do this. But is it visited? Is 1 visited? Yes, it's visited. So inside this is not executed. So we go back to the for loop and find adjacent of 1. So every time this changes, by the way. So that's this S. So currently our S value is what? Currently our S value is 1. So we find adjacent of 1 which are unvisited. Do we have adjacent of 1? So adjacent of 1, 0 and 3, everything is visited. So we have nothing to put inside the stack. So because this is again cannot be executed, we go back to the while loop and take the top element on S. If it is not empty. Is it empty? Yes, it's empty. So we don't get into the stack because it's the stack is it okay, because the stack is empty. It's true. It's true. It's true. This is true. Stack is empty is true, but not true. But here not true is totally false, because not true is false. Since this is false, the execution doesn't get inside the while loop. So everything is done. Let's see how it has displayed. First, 0 to 4. Okay, sorry. Look at first 0, 2, 0, then 2, then 4, then 6. You see? 6. It has displayed in this way. 0, 2, 4, 6. Once it has finished depth wise, then it checks the side way. So once this is completed, then the next step is to display the side way. 5, 2, 4, 0, 2, 4, 6, 0, 2, 4, 6, then 5, 3, 1. Then the side way. 5, 3, 1. First we give priority for the depth and then we check the side way. This is depth first search. I hope everything is clear and thank you for giving me time.